Hello friends, this video on integrals part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 3. Now let's understand the geometrical interpretation of indefinite integral. So let's suppose I have my function fx is equal to 2x. If I want to find integration of this, that is nothing but fx dot dx, and there is nothing but 2x dot dx, correct? And this will come out to be x becomes x square by 2 plus c. So this is nothing but y is x square plus some constant k. So this is the integration of fx is equal to 2x. I can take any values of k. If I take k is equal to 0, my equation becomes y is equal to x square. If I take k is equal to 1, my equation becomes y is equal to x square plus 1. If I take k is equal to 2, this becomes x square plus 3. If I take k is equal to minus 1, this becomes y is equal to x square minus 1. So there's so many equations which you can form from integration of this equation. So let's plot all these graphs. So y is equal to x square will be something like this. Something like this, correct? Y is equal to x square plus 1 will be something like this. If we draw it, will be something like this. Similarly, y is equal to x square plus 2, something like this. Y is equal to x square minus something like this, right? So many graphs you'll get, so many graphs. And these are all integration of y is equal to fx. And there's one thing common, that is you take any point here, let's suppose x is equal to 1, you draw a line from this x is equal to 1 parallel to y axis, and you take any points in this graph, the slope at all these points will be same. There is all this line L1, L2, L3, L4, L5, they all be parallel, correct? And that is how we represent this graph geometrically, this integration geometrically. So if I have my function fx equal to 2x, my integration is nothing but x square plus k. I can take any value of k, so you get so many graphs. But there's one common thing, that is all these graphs are identical. They are just nothing but you move this graph up and down in this y-axis. That's all. And if you take any point and you draw a horizontal line, you find the slopes. You'll see that the slopes are all same. That is, all these graphs you get is identical graphs. And reverse way also true. If you take any of these graphs, you find the dy dx, that is differentiation of this, you get the same value. That is, you take differentiation of any of these, you find def of any of this, you get same value, that is 2x. And that is nothing but slope 2x constant. Correct? That is how geometrically we represent. These are the graphs, so many graphs we have. You can see these are the graphs we have, and the slope is 2x, that is differentiation of this. And if you see for all these graphs, the slope is constant at any point. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.